Saya Ahmad Hafizuddin akan menceritakan tentang bab 2 semiconductor ini. Untuk semiconductor bab 2 ini, saya akan menceritakan tentang diode. Diode ialah sebuah semiconductor yang digunakan di dalam electronic circuit seperti rectifier dan clipper circuit. Saya merekodkan video ini untuk practical work 2. Objektif practical work 2 ini ialah untuk melatihkan pelajar-pelajar untuk bercakap dan membina sosial percakapan mereka untuk masa depan mereka. I will explain the working principle of half-wave rectifier and full-wave rectifier using circuit diagram and demonstrate how the diode allow current flow in one direction and convert it from AC to DC, and I will compare the output waveform of half-wave and full-wave rectifier. To start, the core concept of rectification is the process of converting alternative current, which is AC, into direct current, where the current flow in only one direction. The key component of enabling this is the diode, an electronic device that ideally allows current to flow easily in one direction, which called forward bias, but block current flow in the opposite direction, which is called reverse bias. The concept of half-wave rectifier that it is the simplest form of rectifier. It uses a single diode to allow only one half, either positive or negative, usually positive, of the AC waveform to pass through to the load, blocking the other half. The circuit of the AC voltage source the circuit of the rectifier consists of an AC voltage source, a single diode, and a load resistor, which is RL, connected in a series. As for the working principle of the half-wave rectifier, if it is a positive half cycle, when the AC input voltage is positive, the anode of the diode becomes positive related to the cathode. This puts the diode in forward bias. It acts almost like a closed switch with a small voltage drop, typically around 0.7 volt for silicon diodes. Current flow from the source to the diode to the load resistor and back to the source. The output voltage across the load closely follow the positive half of the input AC waveform. For negative half cycle, when the AC input voltage becomes negative, the anode of the diode becomes negative relative to the cathode. This puts the diode in reverse bias. It acts like an open switch, blocking the flow of current. Ideally, no current flows to the load and the output voltage across is zero during this half cycle. The output voltage for the half-wave rectifier is a series of positive pulses separated by gaps of zero voltage, where the negative half cycle will block. This is pulsating DC, not smooth DC. For the full-wave rectifier, the concept for it utilizes both the positive and negative half cycle of the AC input waveform to produce a DC output. This results in higher efficiency and a smoother DC output compared to the half-wave rectifier. There are two main types of full-wave rectifier, which is center tap and bridge rectifier. We will discuss the center tap full-wave rectifier. For the center tap full-wave rectifier, The circuit of it requires a transformer with a center tap on the secondary winding, two diodes, and a load resistor. The diodes and anodes are connected to the opposite end of the secondary winding, and their cathodes are joined together. The load resistor is connected between this common cathode point and the center tap of the transformer. The working principle of the center tap is the top end of the secondary winding is positive and the bottom end is negative. Diode 1 is forward bias and conduct. The second diode is in reverse bias and blocks the current flow. Current flow from the top end to the first diode to the load resistor from top to bottom and back to the center tap. For the negative half of the cycle, the top end of the secondary winding become negative and the bottom end become positive. Now, the first diode is reverse bias and block. The second diode is forward bias and conduct. The current flow from the bottom end to D2 to the load resistor and back to the center tap. For the output, the current flow to the load during both half cycle always is the same direction. The input consists of a continuous series of positive pulses. I will explain the function of a Klipper circuit. A Klipper circuit, also known as a limiter or amplitude selector, is an electronic circuit designed to prevent an output signal from exceeding a predetermined voltage level without distorting the remaining part of the waveform. Essentially, it clips off or removes portion of an input signal's waveform that lie above or below a specific reference. Klipper circuit modify waveform by effectively flattening the peak of the signal that exceeds the set clipping threshold. Here's a more detailed breakdown of how it works and the modification. For key component of it, the simplest clipper typically use a combination of diodes and resistor. Sometimes a DC voltage source is added to set a specific clipping level other than the diode natural forward voltage drop. A Zener diode can also be used for more precise voltage clipping. When the input voltage rises above or fall below, depending on the circuit configuration, the clipping level determined by the diode's orientation and any bias voltage, the diode becomes forward bias and start conducting. This conduction effectively creates a low resisting path, diverting current and clamping the output voltage at the clipping level. When the input voltage is below the level required to forward bias the diode is reverse biased and acts like an open circuit. In this state, the input signal typically passes to the output without being significantly affected. In summary, a Klipper circuit functions as a voltage limiter. It modifies a waveform by cutting off any part of the signal that exceeds a predefined threshold. This results in an output waveform where the peaks are flattened at the clipping level, while the portion of the waveform within those limits remain largely unchanged. They are widely used for protecting against voltage spike, waveform shaping, and in signal processing application. Okay, ini adalah forward bias yang arus itu akan mengalir dari arus depan ini hingga ke belakang. Ini pula adalah reverse bias. Arus tidak boleh bergerak dari hadapan ini ke sini, tetapi dia boleh bergerak apabila kita terbalikannya dari LED ke resistor. Resistor ini ialah 330,000. Itu saja.
Ini ialah half wave rectifier yang akan menukarkan separuh with AC kepada DC. Ini adalah full wave rectifier yang akan menukarkan kedua-dua wave kepada DC. Ini ianya 4 diode yang dibina mengikut segi 4 diamond.
To measure the output of the half-wave rectifier, we connect the circuit as shown here, and this is the closer look of the clip connection. As shown here, we can see that only half of the waveform is shown. This is because we use the half-wave rectifier. So in conclusion, diodes are an important tool in our everyday life in electricity and electronic. Other than that, rectifier and clipper circuit also play an important role in our daily electrical life. Such example for rectifier is it is used to convert AC to DC, so we can use the DC that is converted to charge our battery in our handheld device. And as for clipper circuit, it is used in protection such as against overvoltage, noise removal, and transmission.